So you want to live on Mars in theory. It's a super cool idea, an expansive high-tech city of the future operating under the protection of shining glass domes, life and luxury on the interplanetary frontier. In practice, though, life on Mars will be rough going for a very long, while those metal buildings and glass domes are great for science fiction, but we won't be seeing those things on Mars anytime this century. If you're serious about occupying the red planet, then the best bet is likely to be either life underground, 3D printing some kind of rock-based structure, or living in a balloon. Today, we are going to advocate for the balloon as the ideal Martian accommodation, or more specifically, a highly engineered, self-sufficient inflatable habitat. This is a technology that has been under development for 3 decades now, and it's just about ready to begin playing a massive role in the future of human spaceflight. Inflatable habitats solve a number of problems that are inherent with trying to keep people alive and well outside of the Earth's atmosphere. They're an excellent solution for future orbiting space stations, and they just might end up being the key to Mars colonization. This is the space race. 3D printing on Mars has been a long-standing frontrunner in the design and engineering of practical Mars colonies. We've seen a few great 3D printing concepts arrive over the past few years, some of them even endorsed and funded by NASA. Those have been covered here on the channel before, and we continue to be big fans of 3D printing in space, but the more time we spend looking into these inflatable habitats, the more inherent flaws start to become visible. With additive manufacturing on Mars, the basic concept behind 3D printing in space is that you would land a fully autonomous robotic system on an alien planet. It would then deploy rovers to go out and scoop up massive amounts of regolith, which is the loose dust and bits of rock that cover the surface. The collected material is then brought back to a high-temperature oven that mixes the regolith with a polymer substance and bakes it until it becomes a sort of extrudable concrete. That concrete material is then laid down by a 3D printing machine that builds up the structure one thin layer at a time. So that all sounds pretty neat, but obviously it's going to require us to land all of those robots on Mars, and then a ton of electricity to power these things while they go about the process of collecting and melting and 3D printing. Then, as an end result, we're left with what is essentially an above-ground cave made from Martian rock, which is very likely going to be physically toxic to human beings. And that hits on another big issue here. We don't actually have a sample of Martian regolith, so we don't fully know what's in it. And we won't know for a few years at least, so the theory that we can just bake it into Play-Doh to make a house is more like an educated guess than a sure bet. Whereas if we go the inflatable route, we prefabricate the entire thing on Earth, load it into a rocket fairing, and ship it to Mars on arrival. The habitat self-inflates, deploys solar panels, powers up, and just waits for a human crew to arrive. When we're talking about establishing the first human settlement on a planet 291 million kilometers away, the most simple solution would most likely be considered the best, and I think we're pretty clear on which one of those ideas offers up the lowest complication: music. Now we can't talk about inflatable space habitats without paying respects to the OG Bigelow Aerospace. Before Musk, Bezos, and Branson, there was an eccentric billionaire named Robert Bigelow who decided that he wanted to get into outer space. Bigelow amassed a fortune as the owner of the Budget Suites of America hotel chain, and in 1998, he leveraged that wealth to found his own aerospace company with the dream of creating hotels in space. We could do a whole documentary just on Robert Bigelow. He is a character to say the least. Anyway, the company got straight to work on a multi-layer expandable space module technology that they were able to license directly from NASA. The Transhab project was an idea concocted for the International Space Station in the late 1990s, but they were never able to secure the necessary funding from members of U.S. Congress. After a decade of private research and development, Bigelow had a viable technology that was ready for a demonstration in outer space. In 2012, NASA provided them $18 million in funding to develop the Bigelow Expandable Activity Module, or BEAM. By 2016, the module was berthed to ISS and successfully inflated to 4 meters in length and 3.23 meters in diameter, with a pressurized volume of 16 cubic meters. BEAM was more like a proof of concept than a functional module of the ISS. It's still up there, inflated and pressurized, but from what I've heard, the astronauts mostly just use it as a closet, and they never leave the door open just in case. But in the long-term study of the BEAM's performance, it's proven that it can withstand micrometeor impacts without taking damage, and levels of cosmic radiation recorded inside the BEAM have been pretty much the same as they are anywhere else on the ISS. So from that one limited test, we can form a pretty decent hypothesis that inflatable space station modules function at least as well as any other space station module. Unfortunately, Bigelow Aerospace collapsed. In March 2020, Robert freaked out, laid off the entire staff, and ceased all operations permanently. Later that year, he went on to found a new institute that was dedicated to researching life after death. Like I said, he's a really interesting dude, so leave a comment if you'd watch a Robert Bigelow video. Luckily for the future of inflatable space HABs, the Sierra Nevada Corporation came along with their newly formed offshoot Sierra Space. This is the same company that has been making the Dream Chaser space plane, and they are partnered with Blue Origin to build the future Orbital Reef Space Station. The large integrated flexible environment or life habitat is carrying on the same basic idea as the Trans-Shab, and the beam before it, the fully inflated life, will be 3 stories tall and 27 feet in diameter, offering up about 1/3 the internal volume of the entire ISS in one single module. In its compacted form, life can be fitted into a standard 5-meter rocket, faring like the one on top of a Falcon 9. Once deployed into orbit, life self-inflates and then uses its own thruster system to maneuver to a final destination in orbit. Sierra is planning to integrate life modules into the upcoming Orbital Reef Station, but the modules are also designed to be fully self-sufficient standalone space stations in their own right, and Sierra has envisioned life as a modular system so multiple habitats can be linked together to form orbital structures with massive internal volumes. So you might be wondering, is it's safe to live inside a space balloon? I mean, going to outer space, and especially visiting an alien planet, are extremely dangerous activities just as a baseline. But all things considered, it doesn't really get much safer than these inflatable habitats. The outer shell may be soft, but it is made up from multiple layers of an ultra-tough Kevlar-like material called Vectron, which is a fiber spun from liquid crystal polymer. And if you look closely at the life prototype, you can see the fabric is woven together kind of like a basket to increase the material strength. Sierra says that when pressurized, their outer shell is stronger than steel, and they've been verifying that with a series of small-scale tests over the past year. Obviously, that includes overpressure testing, where they just keep filling the vessel until it bursts. Those are actually pretty fun to watch, and they help Sierra to begin plotting data points about the consistency and longevity of their product. They also perform ballistic testing with these smaller prototypes. Basically, they take it out and shoot stuff at it to see what happens, varying up the size of the projectile, the speed, and the angle of attack. From the data they've gathered so far, Sierra is already projecting an operational lifespan of about 60 years for the life habitat. But just for the sake of being paranoid, what happens if something does puncture the shell? Does it burst like a balloon? Will you get sucked out into outer space? The answer is no and no. So this is where we have to deprogram our minds from what science fiction has taught us. Space is a vacuum in the sense that it is an extremely low-pressure environment, but it's not like there's a giant Dyson out there just sucking up everything. The ambient pressure in outer space is around -14 psi. The air pressure on Earth at sea level is around +14 psi, so about 30 pounds of pressure differential per square inch. It's not enough to cause an explosive decompression or suck anything out through a hole. If a micrometeorite did puncture the inflatable HAB, it would be like a pinhole in a bicycle tire. Air would leak out, but just slowly and steadily. It could be fixed, is the point. What about radiation? The good news here is that soft shells actually lend themselves very well to highly effective radiation shielding. The best material for blocking radiation is actually hydrogen. This is why you'll often hear people talk about using water as a radiation shield. Polyethylene is a plastic polymer with a very high hydrogen content, and it can be woven into a matrix that can be layered into the shell composition of the inflatable module. If you've worn one of those surgical masks over the past few years, those use a very similar woven polypropylene matrix to capture viruses and stuff. Bigelow has also had some ideas in their old designs about high hydrogen content foam materials that could be integrated into the soft shell to create a very effective radiation shield. Again, leaving the Earth's magnetosphere is extremely dangerous no matter what, but the inflatable habitat is at least as safe, or maybe even safer, than anything else we've got. Now that we know all that, we can get back into how these inflatable habitats could function as a part of a Mars colony. These modules are designed around a solid center core that contains all of the primary systems, communications, life support, power, and all of the hard goods like research equipment. The medical bay and exercise gear are stored in here at launch. Then, after the shell is inflated, the astronauts arrive and move all of these things to the outer areas. There are two distinct design applications here. Zero gravity halves and planetary halves. Zero G is what Sierra has been working on so far, and from an engineering perspective, these are much easier to design. You can separate different areas of the hab using just soft baffles. You don't need a solid floor or stairs or anything rigid on the inside. But they do have plans for future life modules that will function with gravity. For a serious colony on Mars will probably want a combination of ground-based infrastructure and an orbital space station to function as a waypoint in between Earth and Mars. Same idea that NASA is working on with their Lunar Gateway station for the Moon, so the life modules can handle both of those applications. Sierra has an idea that if they link together enough modules, they can form a ring-shaped space station, which could then be rotated to create an artificial gravity effect in the current life habitat design is only based on existing rocket capabilities, but there are much bigger rockets coming soon that will offer much larger cargo fairing sizes. Bigger fairing means the opportunity for a bigger module. In a March 2023 interview with Fraser Cain at Universe Today, the senior director of engineering at Sierra Space, Sean Buckley, revealed that his company is already running the numbers on what they could accomplish with a SpaceX Starship-sized cargo fairing. The Starship is promised to deliver 100 metric tons of mass directly to the surface of Mars, in a fairing that is 9 meters wide at its base and around 17 meters in length. But Elon Musk is already talking about making the upper stage ship even longer, and SpaceX is developing even more powerful Raptor 3 engines, so that could end up being even more capable by the time we're actually flying these things to Mars. Sierra is estimating that, by taking full advantage of Starship, they can create a jumbo-sized life module that would expand to over 2,000 cubic meters in volume. The ISS is only about 900 cubic meters, so with one single launch, Sierra could more than double the working space. Fully inflated, the habitat could be as much as 60 feet in length and 40 to 50 meters in diameter. So with one of those in orbit and one on the ground, we would essentially have a fully functioning Martian infrastructure that would even be relatively safe and comfortable to support a long-term human presence. I think we'll be hard-pressed to find an idea that can really beat that. Meet us back here every week for more updates on everything aerospace industry and interstellar exploration related. Make sure to give the video a thumbs up today if you liked it. That really helps us out for real. And subscribe to the Space Race for more videos just like this. We do one long-form essay and one news update every week. And if you'd like more, we've got 2 more on the screen for you right now.